This next example of ionic bonding is magnesium oxide. So we've got magnesium on the left reacting with oxygen on the right. Magnesium is in group 2, that tells us it's got 2 outer electrons. It's also element number 12, so that tells us in total it's got 12 protons in the middle, 12 plus, and 12 electrons around in shells, arranged 2, 8, 2. So when magnesium reacts, it wants to lose both of its 2 outer electrons. So it's going to lose them. That will mean its electron arrangement is now 2,8, same as the noble gas neon. Because it's lost 2 electrons, it's now got only 10 electrons, it's still got 12 protons, remember the middle doesn't change, so it's got a charge of 2 plus. Where are those electrons going to go? Well, if it's reacting with oxygen, element number 8, has 8 protons in the middle, 8 electrons in shells around the middle, so its electron arrangement is 2,6. The 2 electrons from magnesium are going to go into the outer shell of oxygen. So, oxygen has gained 2 electrons. Electrons are negative, it's gained 2 electrons, so it's 2 minus. So, going back to what we formed, we've now formed an ion of oxygen, we call it an oxide ion, and it's got the same electron configuration as the element neon. 2 in the first shell, 8 in the second, full outer shell, that makes oxygen stable as well. So magnesium has become magnesium 2 plus, oxygen has become O2 minus, and that is a dot cross diagram showing you exactly what's happened to form magnesium oxide. So to summarize again, magnesium only has 2 electrons in its outer shell. So this time we'll only draw the 2 electrons in the outer shell. Oxygen has 6. Again, we won't worry about the inner shells because they never change. It's only the outer shell that changes. So magnesium gives those 2 electrons to oxygen. That leaves magnesium's outermost shell empty. The previous shell, of course, is full. It's lost 2 electrons, so it's 2 plus. Oxygen, 6 electrons of its own in its outer shell, gains 2 from magnesium, becomes 2 minus, and that is magnesium oxide. Compared to the last substance we looked at, sodium chloride, where we had sodium plus attracted to chloride minus, now we've got Mg2 plus attracted to O2 minus. And it shouldn't surprise you really that the bonding in magnesium oxide is much stronger because the charges are both twice as big, twice as strong, and therefore the attraction between magnesium 2 plus and O2 minus is much greater than it is between Na plus and Cl minus. For those of you doing A-level, magnesium oxide has a much higher melting point than sodium chloride because of the stronger bonding. And just to summarize again, if you're asked, well, what actually is ionic bonding? If you want a definition, then ionic bonding is the electrostatic attraction between oppositely charged ions. That is it in a nutshell. What we've seen, oppositely charged ions, what we've seen is how those ions get their opposite charges, but actually the definition of ionic bonding, you only need to quote that sentence, and that could get you 1 or 2 marks in the exam. Nice simple marks, if you can remember that definition.